So our plan here is to get you all pumped up by giving you all the tools and best practices you need to run efficiently on Amazon Aurora. So before I head on, though, I do want to get a sense from you all. So I'm going to do a quick poll. How many of you are aware of Aurora, familiar with Aurora? All right, fair number of hands go up. There's a great deal of innovation that has gone into building this relational database. And there are 2 sessions I would really highly recommend you to go either view or attend. First one is DAT315. It's getting started with Aurora. And that session, the recording for it is now available online, so you can go and watch it. The other session is DAT301. And the repeat of that session is happening tomorrow at 11:30 a.m. So I highly encourage you to attend, or if you can't, then in that case, you can watch the recording in a few days. All right, so let me continue with the polling a little bit more. So bear with me. How many of you are thinking of migrating to Aurora? Fair number of hands, great. And how many of you are currently using Aurora? Just a few. All right, so hopefully by the time we are done, this ratio would change. We have content it's a broad mix of audience here, right? So we have content that would appeal to pretty much every one of you, right? So let's look at what we are going to show you in this session. So firstly, we'll give you a quick overview of Amazon Aurora. And then we'll move on to see different sources from where you can migrate to Amazon Aurora. Right? So we'll start off with the simplest scenarios, which is, let's say, a MySQL compatible database, MariaDB or MySQL. And we'll also call them homogeneous migrations. And then it's possible that you are probably not running a MySQL database today, right? So if you are running a commercial database or you're running a non-relational database, like a NoSQL database, then how you can migrate your data from those sources into Aurora. We'll look at tooling and automation that is available to you for all these scenarios. As a builder, as an application developer, as a database administrator, your job doesn't end when you are done with migrations, right? You want to make sure that you are optimizing your workloads on Aurora so that you are running very efficiently. So we'll look at ways you can improve the performance of your workloads. And finally, once you have everything up and running, you probably also want to maintain deep visibility into what's going on in your databases, what kind of activity is happening. So we have certain capabilities that we'll talk about that you can use for that purpose. Our objective here, finally, is to help you make the most of Aurora. Right? So let's dive right in. So what is Amazon Aurora? Amazon Aurora is a relational database born in the cloud, designed to give you the performance and availability of commercial databases with the simplicity and cost effectiveness of open source databases. So what you get is the best of both worlds. Today, MySQL is drop-in compatible. Today, Aurora is drop-in compatible with MySQL and PostgreSQL. So if you have any applications running on MySQL or running on PostgreSQL, you can simply lift and shift and point to Aurora, and it should ideally work. Now, there's a lot of innovation that has gone into building Aurora. But if there's one fundamental key innovation that I'm going to talk about, it's going to be the storage layer. So in a traditional database, you have different layers. There's query processing, there's caching, there's logging, and there's storage, right? So what we have done is we have taken the logging and storage layers and created a purpose-built, scaled-out, distributed, log-structured storage volume. Now, what this does is takes your data, copies it over 6 times into 3 availability zones. An availability zone in AWS, you can think of it as a cluster of data centers. So that gives you high availability. Your data, depending on the size of your database, also gets striped across hundreds or sometimes thousands of nodes. So with that, you also get very high performance. How much, you might ask? It's 5 times the performance of MySQL. So Aurora continues to be the fastest growing service in AWS's history. Today, 3/4 of top 100 AWS customers use Aurora. This is just a sampling of those customers that we can reference. We have tens of thousands of customers using Aurora today. Okay, so with that context, let's look at the various sources that you can migrate from and what kind of tooling and automation is available to you for that. So we'll start looking at first from the simplest scenario, wherein you're running your MySQL database potentially in RDS, and then work our way towards more involved setups, so commercial databases and non-relational databases. And look at different tooling that is available to you, automation that we make available to you to migrate to Amazon Aurora. I'm going to use the schematic, actually, to walk through the different options and methods that are available to you. So on the top are the different sources, and on the side, we have the different methods you can use to migrate to Amazon Aurora. The options that are highlighted are the ones which we recommend. Of course, the ones with text are the ones which are supported. So let's dive into this, right? RDS Snapshot, of course, is available to you if you're running your database in RDS. And the migration from RDS, if you're using the Snapshot, is very simple. It's a point-and-click operation, and it's also the fastest approach, right? So on the console, if you go in, you can simply click Migrate My Latest Snapshot and restore that snapshot into an Aurora cluster, and that's it. Your migration gets completed at that point. Now, you might want to do this with minimal downtime. So there's an option for that, too. What you can do now is you can create an Aurora read replica. This will set up binary log-based replication between your source, RDS MySQL database, and your destination Aurora cluster. And as soon as the replication completes, at that point, you can cut over and essentially take a very minimal downtime while doing this migration. Now, it's possible that your database that you're running today, MySQL database you're running today, is not on RDS. Maybe you're running it on premises in your data center, or maybe you're self-managing it in EC2. So for that, there are two options. One is a binary backup of your database. The other one is a set of MySQL tools. So let me elaborate a little bit more on that. You would see there are two arrows going back and forth there. The reason is, with backups, you essentially restore your entire database. In scenarios where, let's say, you want only parts or portions of your database to be migrated, so you want more control and flexibility in how you do your migration, MySQL tools are going to be probably more useful for you. And we'll dive into each one of those deeper and walk through when it can come in handy, right? So first off, I'll take the backup setup and walk through it. So how can you take your backups? There are open source tools available, such as Percona Extra Backup. It will create a binary copy of your database. What that means is your migration is really high performance, because you don't have to take your logical dumps, replay those statements on your source database, Amazon Aurora cluster. It's just a binary copy that gets restored in an Aurora cluster. For it to work, what you have to do is that you have to create a backup and store it in an S3 bucket. Once it's in an S3 bucket, beyond that, RDS automation helps you there, right? So on the console, there's point-and-click operation. You can select your backup and restore it to an Aurora cluster. Straightforward, done. Now, you might ask, how do I now achieve minimal downtime while doing the migration? The process is similar to what we discussed in the previous step. So you can, in this step, set up replication, binary log or bin log-based replication between your source database and target Aurora cluster. Once the replication completes, the process is similar, right? You just cut over your application to your target Aurora cluster. So that's great. In this setup, as I said, and with the backup, your entire database gets restored. What if you only want certain tables to be migrated to Aurora? Or let's say you want only certain portions of your table or certain partitions of your tables to be migrated to Aurora. So that's where MySQL tools come in handy. And those tools will give you the flexibility to achieve this. So which tools am I talking about? So with your MySQL installation, you would get MySQL dump and MySQL import. These come with your MySQL installation, and you can use this to take a logical dump of your data and then import that logical dump. Now, one limitation with these tools is that they are single-threaded. So if your client machine has, let's say, 16 vCPUs, this is going to run only one thread to take the backup, and take the logical dump. So for that, you have alternatives. If you really want to utilize the compute capacity on your client instances, in that case, you can use third-party tools such as MyDumper and MyLoader. These are open source and freely available. And what this allows you to do, these tools allow you to do, is you can create multiple threads for taking dumps of your database and then restoring those dumps back onto Aurora cluster. The replication process is similar as we described before. So you set up binlog replication catches up, you cut over. In addition, of course, you can use regular MySQL commands. Right? So these are select into and load from flat files. In addition to that, what is available to you with Aurora is that you can load from an S3 bucket. So you can place a flat file in an S3 bucket, like a regular SQL statement, right? Load from that file in the S3 bucket. Same way, you can also export out to an S3 bucket with select into S3. Okay, so I've been partially referring to something called as a client. The client is essentially the machine that you're using for either importing data into your source database or extracting data out of your, importing data into your target database or extracting data out of your source database. So there are some considerations that you must keep in mind. First one is that these client machines should be as close as possible to your source and target database, respectively. Why is that the case? So let's say you are running your database in EC2, and if your client machine is not on the same VPC or not on the same availability zone, you are essentially incurring additional network latency. Right? So our recommendation is to place it in the same VPC as the source or as the destination database. Right? Now, what happens in case you're running your database on premises? In that case, our recommendation is you use at least 2 clients. First one would be, of course, in your data center closest to your source database. Take the dump, locate into an S3 bucket, and from there, you have another client machine, which will be in the same VPC as your Aurora cluster, and that will ingest the data from the S3 bucket and restore it into your target Aurora cluster. Some of the other considerations with respect to client instances that you might want to keep in mind. Many times when customers contact us, they say that, why should the client matter? Is the server that really matters? Well, in case of migrations, clients are also going to play an important role in terms of the amount of time it is going to take you to migrate, right? So what we recommend or suggest is that you provision a client machine or instance in case of EC2 that has at least one CPU per export or import thread. And especially in scenarios where you are doing real-time processing. Let's say you have compressed your data, and you are doing compression and decompression. In those scenarios, you would want at least one CPU per thread. EC2 instances also support enhanced networking. So make sure you go for those instances, and depending on the size of the instance you choose, you could get up to 25 Gbps of network bandwidth. Similarly, with EC2, you'll attach an EBS volume. Those volumes can support certain level of IOPS. So depending on your migration, let's say you're trying to do a migration of 100 megabytes per second. So make sure that your EBS volume supports 800 megabits of IOPS at least, right? Similarly, if you find that your machine's not really keeping up, the migration's taking too long, what you can do is you can look at OS diagnostics. And some of these metrics, if you're using an EC2 instance, are in fact by default available in CloudWatch. So you think about CPU utilization or memory utilization, that's going to be available in CloudWatch for you, and you can watch what's going on, right? And maybe provision a larger instance. Now let's look at the destination. In this case, it's the Aurora instance, right? So how much should you provision for it? Of course, it's obvious that you have to provision enough capacity to be able to ingest or dump data if you're exporting out of Aurora. What we recommend is that you provision at least 2 CPUs per thread for imports and 1 CPU per thread for exports. If I point back to the storage volume that I described at the start of the presentation, what it allows us to do is that networking is typically not, or rather storage I/O is not typically the problem. The reason being, your data is getting striped across hundreds or thousands of nodes. So that usually is not the bottleneck. And in terms of your provisioned capacity, of course, if you find that your database instance is not scaled up to the point that you need, there's point and scale operations available on the AWS console. So you can just go in and increase the size of your database instance if you want to, or scale it back if you need to. Another question that many customers ask us is that, hey, I have this huge, large table, and it's taking me days along or hours along to import or export out. What do I do? So I'll refer back to the third-party tools, MyDumper. Because these are multi-threaded, they provide you more flexibility. And one of the options with MyDumper is that you can use the rows parameter in it to specify how many rows should be in per chunk of your flat file. So you can take a large table and chunk it up into certain number of smaller pieces. So your exports become faster because they are going through multiple threads. Similarly, when you ingest it with MyLoader, you can specify the number of threads you want to use for importing your data, right? Now, by default, MyDumper and MyLoader will spin up only 4 threads. So our recommendation is if you are using larger instances, for example, an R4 2XL, 2 extra large, you would want to increase the number of threads adjusted to the number of CPUs you have available so that you are making the most use of compute capacity available to you. Another tweak that you should absolutely consider is setting up RPS, or receive packet steering, and RFS, or receive flow steering, on your instances. What do these mean? Essentially, at a high level, RPS means that it will allow you to process your incoming packets through multiple CPUs, right? So better utilization of your CPUs. And RFS is an extension of RPS, which essentially ensures that your incoming packets are being processed by the same CPU, their CPU affinity, so that your cache is being utilized better. Okay. All these slides and the content will be made available to you offline, so no need to note down. You will have access to all this, all right? So that's about migrations from sources which are compatible with MySQL. What about situations where you are not running a MySQL database? Maybe you're running a commercial database. Maybe you're running a NoSQL database, such as MongoDB. So for that, you might want to consider AWS Data Migration Service. And let's dive deeper into it. So what is AWS Data Migration Service? It is a managed service that allows you to easily migrate your data from most of the widely used sources, they are all listed here, to a target destination, right? So in this case, Aurora as well. Now, the process involved in migrations from these non-MySQL compatible sources is 2 steps. Because not all databases are made equal, not all data types are going to be equal, first step that you need to take is to change your schema or migrate your schema. So you can use either native tools available with your source database, or you can use the AWS schema conversion tool to convert your schema. Once the schema is migrated over, DMS can take over. DMS can take your data and through changed data capture, migrate your data into the target database. So how does this work? So essentially, you first provision a replication instance. Once this instance is created, you would connect it to the source and destination databases so that it knows where to move the data from, and create tasks. Tasks define what kind of data that you want to migrate from your source database to destination database. And that's it. DMS then takes care of, through change data capture, migrating your data into your destination database. And once you are done, at that point, you just point your application back to your destination Aurora cluster. Now, many times, customers ask, OK, this is great for heterogeneous migrations, but I have a MySQL database where I've sharded my data across multiple MySQL shards. Is there a way I can consolidate that into Aurora MySQL cluster? Because I get more performance, I can potentially do that and achieve that. So what level of automation and what processes are available to you? Steve is going to walk us through that.
All right.
So Steve, off to you.
All right. Thank you, Cheyenne. All right. So like Cheyenne said, a lot of times you find yourself, you have a MySQL database, and it's too big to fit on a single instance. So you've taken to sharding this across multiple instances, which will give you the performance you need, the throughput that you need, but it can introduce additional management headaches, right? You now have multiple servers to take care of. You have to have a mapping function of some type that will route your traffic to the appropriate instances, et cetera. So let's take a look at what we have right here. On the left, what we have is our initial setup, right? We have 4 shards. The first shard contains what we call our reference data. This would be small tables that we use for lookups, things like that. The other 3 shards are going to have very large tables, or maybe even one very large table that is just essentially partitioned across multiple servers. So the first thing that we're going to want to do in a migration to Aurora is to establish a beachhead. And so what do I mean by a beachhead? Well, our goal is to move everything into a single Aurora instance, right? A single Aurora cluster. And so what we're going to do is we're going to create that Aurora cluster, and we're going to move the reference data first, because that is central to everything else, and it's also generally the smaller of all of the shards. So once we've done that, I think it's important to note that Aurora MySQL, as it stands today, is wire compatible with MySQL 5.6. So when we're looking at the picture on the right-hand side, we still have 4 MySQL databases as far as your application is concerned. So once we've done this and we have migrated that data over, the next thing that we want to do, and so we end up in this state right here. So once we're in this state, then it's time to validate. Like I said, you have your application. It still doesn't know the difference between which one is your Aurora instance and which one are your other shards. From here, we can then, one by one, start folding these shards into that Aurora cluster. We don't have to do everything all at once. We're going to just move the next shard, and then we'll validate, and we'll repeat until we end up with the single Aurora cluster. And at this point, even though we still show a mapping function up here, you really don't need one at this point because you're just talking to a single endpoint. You have one thing to maintain. And with Aurora being a managed service, a lot of that undifferentiated heavy lifting, like backups, like high availability, and scalability is managed automatically for you. So this all sounds great in concept, but what if we were to take a look at a demo and see this actually in practice? What I have here is I have a database for a ticketing system for sporting events. If you look on the left, we have our reference data. This is the master shard. And so you can tell by looking at the tables in here, these are the reference tables. They don't generally have a lot of data in them relative to the other 2 shards, which have ticket data and purchase history data in them. So those are very large, and they may be partitioned. Maybe one of them is for baseball, on the first shard, and football on the second shard, or however you've decided to carve up the data so that you can distribute that load for your reads and for your writes. So right here, we have our 3 shards. The first one, the top one, is the master shard. The first thing we're going to do is we're going to select that, and as Cheyenne was talking about earlier, we can say create an Aurora read replica. So in here, we want to go ahead and select the size of the instance we're going to use. For now, we won't make it multi-AZ. We're going to give it a name, and then we're going to scroll down. We'll select the VPC security group that it's in, for now default, and then we're going to accept the rest of these default values for the time being. In your case, you may choose different values depending on your circumstance. We're now launching the replica. You can see it's currently creating. Now it's available. Now it's available, and it's in sync with my current master. So now that that is in sync, the next thing we're going to do is we're going to promote that read replica. And at this point, we now have our beachhead. We've now migrated that master shard from RDS MySQL into our Aurora MySQL cluster. And we have an Aurora MySQL cluster to work with. Now, in here, what we're going to do is we're going to just stop that master and the previous master. And the reason why is we still want to hold on to that data until we're done with our migration. It gives us, a little bit of a safe feeling to be able to roll back if we should need to. At this point, the master is stopped, and the next thing we're going to do is we're going to create a parameter group. And a parameter group is how you set a lot of things that you would normally set through startup configurations and things like that in MySQL. In this case, what we want to do is we want to be able to enable CDC, change data capture, within our other two shards. And so the way that we do that with MySQL is we're going to do that with binlog. So we're going to go ahead and turn off the binlog checksum, and we're going to change the binlog format from mixed to row, and save changes. And so we now have a new parameter group. So now we're going to go to each one of our shards, shard 1 and 2, and we're going to change the database parameter group. And we want to check apply immediately. If you don't do this, then this won't happen until your next maintenance cycle in RDS. So we've just applied that for the first shard, and so we're going to go ahead. We'll do that for the second shard now as well. Again, check apply immediately. All right, so we've now applied that parameter group to both shards. With some parameters, depending on the parameter in question, you need to reboot the instances as well. In this case, when we're enabling binlog replication on RDS MySQL, you do need to reboot them. So right now they're rebooting, and now they're available. All right, so now what we're going to do is we're going to connect to each one of those shards, right? We've enabled binlog replication on both of those shards, and so we need to make sure that we can keep the binlogs on there for 24 hours, right? So that we don't lose those and fall out of sync. And so all we're doing here, normally you would need super privileges to modify how long you're maintaining binlogs. Since we don't expose super privileges in RDS, we instead have these helper functions like this one right here that allows you to set whatever that binlog retention period is that you need. So in this case, we're just connecting to each one of them, and we're just calling mysql.rds.setConfiguration binlog retention hours and setting it to 24. The net result is that both of those will keep those binlogs for 24 hours. And we exit from there, and now we're into the DMS console. In DMS, we're going to create a replication instance. We'll go ahead and give it a name. We'll name it Aurora Migration, give it a description, and then we're going to just accept the defaults for the time being. We'll click Create Replication Instance. It's creating, and now it's available. The next thing we need to do is we need to create endpoints. So it's important to note that this replication instance is really just a special purpose EC2 instance whose job it is to move the data from your source to your targets. Once we have this replication instance, we're creating these endpoints. In this case, we're creating a source endpoint for the first shard. We're specifying that it's a MySQL source engine. We give it the server name, the port to connect to. Optionally, you can specify to use SSL so that you're encrypting your data in flight. And then we're going to click on Run Test at the bottom. And what this is doing is establishing that the replication instance can talk to that source. So once that test is completed and it's successful, you know that we've now established that leg from your source database to the replication instance. So we're going to go back in, and we're going to do the same thing again, this time for the second shard. The only thing that's changing here, really, is we're giving it a different endpoint identifier, or name, and we are giving it a different endpoint, but again, run the test. So at this point, we now have our replication instance in place. We've created endpoints to both of the sources, and now we need to create another endpoint to the target. This one, of course, will point to our newly created Aurora cluster. Specify the target engine as Aurora, specify the server name, the port, optionally SSL, username and password. And then, again, we'll want to test this one as well. So at this point, we've established connectivity all the way from both of our sources to the replication instance and from the replication instance to the target. The next thing we're going to do is create the task. The task is what is actually going to move the data. The task executes on the replication instance and will actually move the data it will read it from the source and write it to the destination. In this case, we're saying migrate existing data and replicate ongoing changes. We get a warning telling us to go ahead and extend the bin log retention period for 24 hours. We did that just a couple of steps ago when we logged into those instances and called that function. We want to make sure that we enable logging. So DMS is very reliable, works very well, but in the off chance that something goes sideways, you want to make sure that you're able to look through the log and find out exactly what happened. What we're doing here is we're saying that we're defining the tables that we want to migrate. So we're saying where the schema name is DMS sample, and well, first, before that, we said where the DMS name is DMS sample, and then the table name is like a wildcard. So that means go ahead and include everything. Then we want to move that. So we want to move everything, every table. But then you saw we went through and we added another one that said except for where the table name is like person. So now we've created one task for shard number 1. So that's up, it's running, it's actively replicating data right now. We're going back in, we're doing the same thing again for shard number 2. And we'll go through, we're going to enable logging. Again, we come down to the table mappings. This is where we're going to say schema name is DMS sample, table name is like wildcard. Add that in. We're going to, again, say where schema name is like DMS sample, and the table name is like person. Then we're going to say exclude, so do not include that, create that task. At this point, you see that there's one that's starting, one that's creating. Now they're both in the starting status. We'll give it another second here. And now they are both in the running status, running and starting. And eventually, they both move into the running state. You can see the progress bar on the right indicating how far we've come along. So now, we're capturing the ongoing changes here, right? It's not just a dump, copy, and load. We're going to generate some other traffic. So what we're doing here is we've created a function on one of the shards to generate random ticket activity. So it's going to just create a whole bunch of new ticket orders in our ticket ordering system. So you can see that that's up and running. And so now, when we look at the table statistics, you can see in the table statistics, all the way to the right, you can see the total number of rows that have been migrated. And then what you can see is that the numbers under inserts and updates are also changing every time we refresh. And the reason for that is because we've already, you can see in the percent complete at the top, we've moved 100% of the original data, and now we're capturing additional changes that are coming into the system. At this point, we're ready to go ahead and shut down those other 2 shards and start running all of our traffic off of the Aurora cluster itself. We have additional resources available to you online, the Aurora Migration Handbook, another one that's migrating your databases to Aurora, and then an absolute must-read is the best practices for MySQL to Aurora migrations. So now that we have moved our data into Amazon Aurora, and we've consolidated our shards, we've folded them all into a single Amazon Aurora cluster, now we have our database on there and our application is running on there. So the question now is, how do we optimize that workload that's running on Amazon Aurora? I wanted to use this slide again. I know that we saw it earlier, but I think that it's important to reiterate that Amazon Aurora is fundamentally different than stock MySQL in many ways, but primarily in the way that we handle the storage. So when you're looking at an Aurora instance, you need to know that we don't store the pages or any data on the instance itself. All of that data is sent down to this shared storage volume. And since we handle this very differently, in fact, we don't even write pages out from the master where you're doing the writes. The only thing that we're writing down to this storage volume are redo logs. And then the storage volume, the nodes that make up the storage volume, are intelligent enough to take those redo logs and create pages on the fly as needed. And so since we're handling the I/O in such a completely different way, when you're thinking about how do I normally tune and performance tune a MySQL database, those things don't apply. So these settings that we have listed up here are settings that if you were otherwise running a MySQL database that was running on a block store instance, EBS volumes, ephemeral volumes, on-premise, these would be parameters that you very well may be interested in tuning. They have zero impact on Amazon Aurora because of how we handle that data differently. Additionally, we have the advantage of running an enormous fleet, right, of databases. We have all of these Aurora instances that are running all of the time, and we know that if the performance, what the performance profile looks like, right, and how to best tune an Aurora instance. And so we've done that, and we've taken those best practices, and we have pre-tuned these settings that you would otherwise normally tune. And these settings are, the way they're tuned has a lot to do with the instance type and the instance size. And so you'll find if you look at these that depending on what type of instance you have and the size, which has a direct impact, of course, on how much memory, CPUs, et cetera, that are part of that instance, these will be tuned specifically for those. Now, when we're talking about the subject of debugging or performance tuning, I think that it's very important to ask yourself, the very first question to ask yourself is the application running well, right? A lot of times, people will have a tendency to sort of preemptively tune a database engine or an application or anything else. So I would suggest that, the very first thing you ask is the application running well? If it is, well then we're good. We don't really need to change anything at all, right? If it's not, then the next question you want to ask yourself is the application not performing well because of the database? Because there are, of course, a number of different moving parts, and so we want to isolate, that it is, in fact, the database that is the source of the problem. So how do you do that? Well, the database, at the end of the day, the point of the database is to store data and to retrieve data, right? And so the metrics that will give you probably the best, for most workloads, give you the best idea of how efficiently your database is doing that is select latency, select throughput, DML latency, and DML throughput. What these are saying is how quickly, when I do a select or a DML statement, how quickly is that coming back? That's the latency, of course, right? And then the throughput is how many of these commands, how many of these queries are being executed in parallel, right? And so since we have these numbers, then the next question is, well, what are good numbers? What is a good select latency, for example? And again, that will depend very much on what your particular workload is. So what I would suggest is that when your application is up and running and is performing well, to baseline the system, to say, this is what my select latency is when the application is running well. This is what my throughput looks like when the application is running well. So in that way, if the number deviates significantly from what you know to be a good number, then okay, now we've got a problem, right? So if we've determined that we actually do have a problem and we want to look into it, then we need to locate the bottleneck, right? And so frequently there are 4, you'll notice there are only 3 listed up here, but there are typically 4 points of contention, right? One is the CPU. Sometimes you have workloads that drive the CPU through the roof, and so the workload is very CPU bound. Sometimes it's memory. You don't have enough memory to, for your buffer pool or for your results cache or for anything else, right? Sometimes it's the network. And then the 4th one that you don't see on here is disk I/O. You're not going to have disk I/O as a bottleneck with Amazon Aurora. Because like Cheyenne was saying, if you have a cluster, your data is actually split off into 10 gigabyte segments. And each one of those 10 gigabyte segments is split across 6 different actual storage nodes. So depending on the size of your cluster, you very likely have hundreds, if not thousands, of storage nodes that have locally attached SSD storage that is very rapidly able to serve up your disk I/O needs. What's more likely is perhaps the network throughput, because again, Amazon Aurora is communicating with all of these storage nodes across the network. And that's why I personally was particularly most excited about the release of the R4 types just a few weeks ago, Because the R416XL, yes, it does have twice the memory and twice the CPU of the R38XL, but it also has 2.5 times as much network throughput, 25 gigabits per second. And so that allows us to drive nearly 250,000 writes per second on a single R416XL. That is due in very large part to that very large pipe that we have. And so when you're looking at these, there are two ways to go. One way that you can address these, if you identify that any one of these is your bottleneck, is to resize the instance, right? You can go up in instance size, and that's sort of the quick way, the easy way to address one of these bottlenecks. Sometimes, though, it's important to actually identify what the problematic queries are or what it is that is driving that resource utilization and pushing it. And so for that, we generally suggest that you would use the same MySQL tools that you use today to diagnose performance problems in your existing MySQL environment. Again, it's very important to remember that Aurora MySQL is, as far as the application is concerned, MySQL 5.6. We do a lot of stuff on the back end that really improves performance, but as far as the wire compatibility and the tools that work with it, it is still MySQL 5.6. So some other things to consider. Cheyenne was talking about doing migrations, and he talked a lot about tuning the client. Those settings are great for migrations, but they're also just as equally as important for running your ongoing workloads. So you want to make sure that you tune the client network, right? With the RPS, you want to make sure that you have those settings configured so that you are maximizing the throughput from your client. You want to make sure that you batch statements to the server. And what do I mean by that? I don't mean that every statement needs to be 1,000 records at a time that are being put in, but with any relational database system, they work best on sets of data. A great example would be if you were going to insert a bunch of data into a table in a relational engine, you obviously want to do that with a number of them at once rather than singleton inserts. The singleton inserts on really any relational engine will always be slower. And you also want to minimize that network chattiness. That's something else that you can address by, when possible, batching commands together. Another thing to look at when we're considering memory, which was one of the other potential bottlenecks, is the query cache. So in MySQL 5.6, in MySQL, and also in Aurora, there is a query cache where when you issue a select query, the data is retrieved, the query is satisfied, it's returned to the client, and then that query and that result are stored in memory. And in some cases, where that query is likely to be issued again, that's a good thing, because the next time that exact query, byte for byte, is issued to the server, then there's no reason for the server to query. The server doesn't go back into the engine and query anything, it just returns the same result set back. A lot of times, you don't get that back. Maybe your workload is not one that works well with that. Maybe you have a very write-heavy workload. Maybe there's a high degree of change in your queries, your select queries that are coming in. And so when you're looking at the query cache, you have to ask yourself the question, what is the payback that I'm getting out of using the query cache? Memory is like gold in a relational database engine because database pages that are read off the disk are kept in memory in a buffer pool until they need to be flushed out. Usually it's because of memory pressure. You don't have enough memory. When you're using the query cache, you're carving off a chunk of your memory to handle that query cache. And if you're not getting your return on investment from that query cache, you may want to consider disabling the query cache and then releasing that memory back to the buffer pool where those database pages that you're reading in can be stored, which will in turn mean less trips back to disk. Index statistics. With MySQL, there is an option to use persistent statistics. And we recommend that you do this. And we also recommend that you adjust the sample page size that you use when you create these persistent statistics. The default is 20 pages. If you have a 20-page table, That's fantastic. You'll have a very representative measure of what the statistics are for your table. If you have a 5 terabyte table, then those 20 pages may not be very representative of the actual data in that table. And so you want to play around with that number a little bit, but don't be afraid to dial that up from its default of 20 so that you can get what you feel is an adequate representation of the data that's in your actual tables. Query plans. We want to make sure, this is old school, sort of 101 DBA managing a database. You want to look at the explain plan for your queries, especially if you're able to identify that there's a problematic query. You're going to want to take a look at that and find out why is it problematic. Am I missing an index? Is there something else that I could do to improve the performance here, which might save me CPU or I/O or whatever? And then, if necessary, don't be afraid to use optimizer hints as well. For I/O-bound workloads, the buffer cache hit ratio is the metric you want to look at. Like I was saying earlier, the buffer cache or buffer pool is a segment of memory, usually the largest segment of memory in a database system like this, where when those pages are read off of the disk, they're stored in memory so that the database server just has to hit them from memory and doesn't have to make that expensive trip back to disk, regardless of the engine that you're running on. The buffer cache hit ratio says this is the percentage of times I was able to find those pages in memory and did not have to go back to disk to satisfy the query. We generally look at numbers 99% or higher is what we're looking for on that. Maybe 99.5% or higher. Very high number in there. When we say upgrade if needed, we're saying maybe you need to use a larger instance. If you use a larger instance, you have more memory, your buffer pool is larger, you can fit more pages into memory, and so you will likely have a higher buffer cache hit ratio. There are a number of features that come with MySQL, and a lot of those features are still available in Aurora. Binary logging, general logs, and a number of other features. They have different purposes. I would caution you to consider why you're enabling or using a given feature before you do so. A lot of times they have additional impact to performance. If you are using Aurora by itself and you're using Aurora replicas rather than replicas outside of the cluster, you don't need to use binlog replication. Aurora does not use binlog replication to communicate with the read replicas in an Aurora cluster. The only time that you need to use binlog replication or enable it is if you're copying data outside of the cluster. And you might be doing that because you're replicating to another MySQL instance, maybe you're replicating to another Aurora cluster. There are different reasons for that, but generally you don't need it if you're just operating within one cluster. Logs, take advantage of the slow query log. Move long-running queries to the read replicas rather than running them on the master. Those are just a couple of other ideas that you can use to offload some of that traffic and to identify what are some of the problematic queries. As far as the queries and transactions, you can use show process list and show NODB status just like you would with MySQL. Like I said, we're still working with the NODB engine. It's still MySQL wire compatible. And then another thing that I think is frequently overlooked is re-architecting the application. And that sounds perhaps a little bit daunting, but it doesn't have to be. Sometimes I've worked with some customers that they're using a relational engine in a way that maybe that particular workload would be better suited on a different type of database engine. Maybe a NoSQL engine, maybe a data warehouse, something else. So consider that. Consider how you're using it. Amazon Aurora, where it really shines, where it really excels, is with a lot of parallel queries. The benchmark we talk about when we talk about the performance being 5 times better than stock MySQL, we're not saying that a single query is faster. We're saying that we can handle 5 times the query throughput in parallel. So 500, 600,000 selects per second in parallel. 200, 230,000 DML statements, writes per second in parallel. Right? That's where Amazon Aurora really shines. And we always want to use the best tool for the best job, right? Transaction isolation level. This is another thing to consider. Out of the box, Aurora uses repeatable read. For most cases, that's fine. Depending on your application and your needs, you may use a lower transaction isolation level, maybe read committed, read uncommitted. I would stress that, like with any other feature that deviates from, the defaults, that you fully understand what it means to change the transaction isolation level and what impact that will have to your application. But in many scenarios, that can actually lead to a performance improvement as well. So we've moved all of our data into Aurora. We're up and running. We've got everything tuned. Everything is humming along. The next thing we want to do is look at auditing, monitoring, and managing this Aurora cluster on an ongoing basis, right? So database activity monitoring, currently with Amazon Aurora, audit logs can be written directly to CloudWatch. And when they're written to CloudWatch, if you are familiar with and have used CloudWatch before, you know that CloudWatch logs also integrates with AWS Lambda. So Lambda could allow you could potentially respond to specific events that are happening in your logs, in your audit logs, programmatically without having to do anything manually. In addition, you can create alerts just as part of CloudWatch itself, so that maybe you receive alerts through SNS when a certain event happens in your logs. So you can automate a lot of that. You can also take those logs and export them to S3. And when you export them to S3, then you can use Amazon Athena or Amazon QuickSight to further analyze those logs and maybe extract other information out of those as you need. This right here, I know that it's a lot of text. Like Cheyenne was saying, this will all be available online for you to view at your leisure. But this is just a simple bash script that exports those CloudWatch logs into an S3 bucket. It's pretty straightforward. It's not that many lines of code, and it has comments in it. So it's a pretty easy thing to do to export those audit logs into S3. We have a couple of blogs that I would recommend that you look into that will detail this a little bit more. The first one is monitoring Amazon Aurora audit events with Amazon CloudWatch. And the second one is, I'll let you read it for yourself. I don't want to read it out loud. It's a long title, but in short, this will show you how to do exactly what we were just discussing in the previous slide. The next thing I want to talk about is Aurora read replicas, right? So, there's that picture again with the shared storage volume, and we've got the primary and the replicas on there. I can't emphasize enough, what a game changer this is for a lot of our customers. Because traditionally, in this type of a scenario, you would have a primary, and then you would have some read replicas. And so what happens if you want to have a read replica with MySQL? Well, you need to do a dump of the data, you need to copy it to that read replica, you need to load it, and then you need to apply bin logs to it until it gets caught up. And depending on the size of the initial data set, depending on the volume of write activity, which then impacts the size of the binary logs, that could take hours, it could take days, it could take a very long time. And that means that you have to have those read replicas online all of the time. You don't just arbitrarily spin up read replicas and tear them down, because it takes too much effort to spin them up to begin with. Additionally, depending on how much write throughput you have, how many changes are being made to that database, the binary log could fall very far behind. Binary log application in 5.6 is a single threaded operation. So if you're generating a bunch of traffic on your master and you copy all those bin logs over to your read replica, you're still applying them one at a time in a single thread on that read replica. And so that, it's not uncommon for read replicas to be minutes or hours or, again, potentially days behind, depending on what that write throughput is. With Amazon Aurora, we don't use bin logs. Instead, we write to the shared storage volume. And so when we bring a read replica online, when we bring an Amazon replica online, it's just a compute head. So the time that it takes to bring an Amazon replica, an Aurora replica online, is the time that it takes to boot up that EC2 instance. Because when that instance comes online, it just attaches to that already existing shared storage volume and is able to start taking traffic, usually within, well, we'll call it a minute. So we've just gone from taking hours to set up a read replica to about a minute. So that's very powerful. Another thing is that since we're using this shared storage volume, we're not dependent on the bin log. Our average Amazon Aurora replica latency is 10 to 20 milliseconds. That is regardless of what your write throughput is. So you could have as your master an R4 16x large and just be hammering that with tons of traffic, tons of write activity, and then have your replicas be only a handful of milliseconds behind. I mean, that enables entirely new workloads altogether. I have some customers that have said, we couldn't leave Aurora, not because we can't get our data out, but because there's not another tool around that will give us read replicas with that small of replica lag. Now, to add on top of this, we just recently added auto-scaling for Aurora replicas. And so, again, it wouldn't be practical to auto-scale MySQL read replicas because it takes so long to spin them up. Since it only takes about a minute or two to spin up a replica in Aurora, then we're able to automatically scale those and add additional read replicas behind a load-balanced reader endpoint. When I say load-balanced, we use DNS round robin. So every time that you hit that endpoint, you'll get a different IP address. It is worth noting that going back to the configuring the client configuration, DNS caching is something to pay very close attention to when you're using Aurora. Because we manage the DNS for you. With that reader endpoint, for example, it's an alias, it's a DNS alias. We have all of the nodes that sit behind it, and our TTL is very short. It's only a couple of seconds. But if your client application is caching DNS entries for 30 seconds, a minute, or whatever it is, then that will make it difficult when we're dynamically adding additional readers, or in the event of a failover. Because in the event of a failover, we're going to take one of your read replicas that you specify. You can specify the failover order, and we will swap that in as the new master. So it's important that you're either not caching DNS on your client, or that you are dialing that number down to a very low number. And that is all that we have for today. I would encourage you to fill out your surveys for this session, and Cheyenne and I will be around to answer any questions if anybody has any questions. Thank you.